All right, so this is on page 3 of your packet. So it says, when sailing a boat creates waves, a bow wave builds up under the front of the boat. Under normal conditions, it's not possible for the boat to have enough power to break through this bow wave and surf on the front of it. So the boat has a kind of speed limit called hull speed. However, the boat can exceed hull speed if there is a great amount of wind power or power from other sources. The hull speed of a sailboat depends on the waterline length of the boat, which is the length of the boat at the point in which it sits in the water. I know, like, you're sitting there going, I have no idea what just was said. Like, they didn't tell us anything important in that, right? Okay, so let's look at this. The formula is given by H equals 1.34 square root of L, where H is the hull speed in knots, and L is the water line length of the boat in feet. Okay, that's probably the most important part. The rest of that stuff, like, who cares about sailing, right? Okay, I mean, like, unless you care about sailing, I'm so sorry. Okay, so it says, which variable is your input? Okay, so let's think about this equation really quick. If I increase my length, what's going to happen to my speed? Well, let's put this in terms that we know, because, like, we don't sail, right? Like, we don't. Okay, so think about your swimmers, okay? What does your stereotypical swimmer body look like?
White skin, sexy.
White? Ah, yikes. Okay, so how tall is your stereotypical swimmer? Okay, they're taller. Michael Phelps, he's a big dude, right? Like, that man's massive. He's like 6'3", okay? All right, so if you have like a 4'5" person up against a 6'4" person, who gonna win? I mean, unless they like doggy paddling fast, like, I don't think it's gonna happen, right? Okay, so with that being said, if we increase our length of our boat, then our speed is gonna increase. So what is our input? What does the word input mean? Let's focus. It's what you're inserting. So, like your domain, right? So, this is going to be your length. This is going to be your length or your L variable. Dude, that just took me 2 minutes. So, now what we're going to do is we're going to create a table for our graph. Okay? So, this up here at the top is our equation that they just gave us, right? Okay? So, if you want to rewrite it, that's fine. If you don't, that's okay. You're going to use that formula to fill out the following table and create a graph. So you see how they give us all these x values or all these L values right here? What we're going to do is we're going to take these and put them into this equation, and we're going to get a y value or an h value. And the way we're going to do that is we're going to take our graphing calculator, not our phone calculator, and we're going to type 1.34 times the square root of 10. And the way you put that square root is you're going to hit that second button, and then you're going to hit that x squared button. So you're going to get 4.2, and the reason why I'm going to put 4.2 is it says round to the nearest tenth. That 10th place is 1 decimal point after the decimal. Yeah? So 1 decimal place after the decimal point. So it should be 1 after. So you're rounding this number. Okay? So now what you're going to do is you're going to take 20 and you're going to plug it in. Instead of putting 10, you're going to put 20 in. Okay? So you're going to plug in each one of those numbers. Okay? So take a second, try plugging those in. So if you plug in 30, you're going to get 7.3. If you plug in 40, you're going to get 8.5. If you plug in 50, you're going to get 9.5. And 70 is going to be 11.2. Okay? Okay, so now we're going to graph this. And so we're going to label the axis first. Okay, so on the x-axis, what was our input over here? What was that? Okay, so it was our length that we were putting in, right? Which was measured in feet. What was our y values? H, which is also measured in knots. Do we know what a knot is?
Yeah, you get them in your hair and you like.
Yikes. Yikes. Okay, so do we actually know what knots are?
No.
Okay, So knots are actually how you calculate speed for boats. Okay, so you know how we like drive and we're like miles per hour. Okay, knots are basically the equivalent of that. Okay, and actually one knot equals 1.15 miles per hour. Like if you didn't know that, I mean it's cool knowing. It was a Jeopardy question a couple months back. Okay, so now what you're gonna do is you're going to number your axes. Shh. You're going to number your axes. So what were they going up by over here on the x values? Tens. Okay, so I'm going to do that same process over here, except I'm going to skip a line in between just because it makes it easier to see. Okay. So I'm going to go up by tens because on my table it's going up by tens, right? For my y values, this is where we can have kind of like a discussion depending on like what the test is actually asking you to do. Okay, so for our table, we start at what y value? 4.2. Okay, so what we're going to do is we're going to insert this little breaker. It kind of looks like the lightning bolt from Harry Potter. Yeah? No? Maybe? Just me. Okay. So we're going to insert this little breaker. I don't know the actual term for this one. My teachers always called it like a breaker for the graph. Okay. So, and we're going to be able to start our y values at 4. Okay. So this breaker is really saying like, hey, there's a bunch of numbers in between here, but we're going to ignore that. We're going to shorten our graph. That's really what it says in that tone. Yes. Okay. Do what? It's okay. That's okay. The breaker just lets me set wherever I want that starting point to be. Okay? And then we're going to increase by 1, but we're going to skip 1 in between. The reason why I'm going to skip 1 in between, one line in between, is to allow us to see these points, like these decimal points. Okay? So I go all the way up to... We got to go up to 11, and we got to go past that because we had 11.2, right? Now, I'm going to level with you. If you wanted to go through and you wanted to write out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 over here, that's fine. You can do that as long as it's consistent. You just want it to make the best graph possible. But according to my table, this is going to be the best graph according to my table. Yeah, like that's how we're setting this up. Okay, so now we're going to actually graph our points. So we're going to graph 10, 4.2. So I'm going to go over to 10, and I'm going to go up to 4.2. Okay, then I have 20, 6. So I'm going to go to the right 20 and up to 6. 30, 7.3. Sorry. 40, 8.5. So that means I'm going to go over to 40 and up to 8.5. 50, 9.5. And 60, 10.4. 70, 11.2. All right, looking like a whole hot mess. Yeah? Yep. Somebody in my last class was like, this looks like a linear line. I was like, but it's not. How do I know this isn't linear? Because it's not, but why else? Because it's got a square root. It's not linear because it's got a square root, right? Okay? So, on question 2, it says, should you connect your points on your graphs? Explain. Why? Because it's not linear, okay? But we've got quadratics that we connect, right? And we've got, like, cubics that we connect, right? So what does connecting the dots actually mean? Why do we do that? Okay, so we're gonna connect them. Okay, yeah, I know. So terrible. So tragic. Okay, so we are going to connect them. Look at that awful line. Oh my Lanta. Who does this? Who am I? Okay, so yes, we're going to connect them, and the reason why is because it's a function, and it shows the relationship between length and speed. Cool? Now, if we had them not connected, that would be called a scatter plot. That just shows trends. Okay, so on number 3, it said that the longest yacht boat was 233, right? And then it wants us to calculate the speed. So all you're gonna do is you're gonna take that equation that we had at the original, in the very beginning, and you're gonna plug in 233 into that. Plug that into your calculator, y'all.
Wait.
1.34 times the square root of 233. And then hit enter.
1.34 just relevant?
1.34, they gave us the equation, but that would, I assume, has to do something with the length. Okay. Okay, so this is going to give us 20.5. And what units are we using? Knots. We're tying a bunch of knots. Okay? All right. So I want you to take a moment. Studio again. All right. What is average rate of change? What does that mess mean? Oh my God. Think back to Algebra 1. What is it called? What's another word for it?
Oh. Average rate of change?
Yeah. So, who said it? Oh, yes. Slope. Slope. Oh, yeah. There it is. I was like, I'm going to say it 4 times and somebody's going to say it. Okay, so slope. Fun fact, I don't give you the slope formula, so you got to have this mess memorized. Yeah, for real. Okay, so really quick. So you see this 30 and this 70? So 30 is going to be your x1 and 70 is going to be your x2. Where do you think we're going to get our y1 or y2 from? The table. So when x is 30, what's y? 7.3. When x is 70, what's y? Okay, so those are going to be my y2 and my y1.
Okay, wait, can you slow down?
Yeah, we can. Sorry.
Okay, wait, x squared is 70. I mean, x2 is 70.
Yeah. Okay, so for my visual people, here it is. This is what you're plugging in, all them colors. Okay? And you're plugging all of this into this equation. So that's going to give you 11.2 minus 7.3. And we're going to put that over 70 minus 30. When we subtract what's in the top, we're going to get 3.9. When we subtract what's in the bottom, we're going to get 40. So when we divide those two together, we're going to get 0.0975. And we're going to put it in knots per feet. And the reason why that's going to be my units, oh, that's looking like a hot mess. The reason why that's going to be my units is because look at what's in the top over here. This 11.2 and that 7.3, those are knots. In the bottom, that's going to be my feet because those are in feet. So this is going to be knots divided by feet. So for domain, that's talking about my x values, right? Yeah? No? Maybe?
Yeah.
Okay. So my x values, what's my smallest length of my boat that you could possibly have? 0. Why do I say 0? Because you can have no boat.
Oh.
I got no boat. Okay. So, right? Okay. So what about the biggest length? What is my biggest length? Look back at problem number 3. Look at problem number 3. What did it tell me about problem number 3? The biggest yacht boat has a length of, boom, there it is. But talking about my range, we're looking at the lowest speed. If I got no boat, where am I going? Nowhere. So that's going to be 0 right there, right? Okay, what about my biggest range? That's going to be 233 plugged into that equation, which up here, we did that already. That's going to be 20.5 knots. I mean, 20 miles per hour with a boat, that's just working off the wind.